Class, one of the new topics covered that was not in intro chemistry is the law of multiple proportions. For the exam, I expect you to understand this law both qualitatively and quantitatively. So I am going to give an example. Okay. So my example is N and O. Let's think about two particular molecules that can be formed with N and O. So one would be nitric oxide. Nitric oxide is NO. And now let us look for a moment at nitrous oxide. Nitrous oxide is N2O. Okay, so as you can see, both of these molecules are made of nitrogen and oxygen, but they are in different ratios. So let's look at the mathematics to prove to us that yes, these two molecules, nitric and nitrous oxide, obey the law of multiple proportions. So in order to prove this mathematically, the best case scenario is to assume 1 mole of each. So if you have 1 mole of NO, nitric oxide, we'll do NO first. 1 mole of NO, nitrogen, is 14.0067, 14.0067 grams. And for oxygen, it's 15.9994 grams. What does that equal to? Do the ratio 14.0067 divided by 15.9994. What does that equal to? 0.875. 0.875. Grams go away. Now let's look at nitrous oxide and 2O. So we have 2 times A, 14.0067 grams, divided by 15.9994 grams, which is going to equal 2 times 14.0067. So we get 28.013, 28.013 grams, divided by 15.9994 grams, which equals 1.75, 1.75. Okay, so what you want to do is you want to put the larger divided by the smaller and put a question mark. Does that equal a whole number? So if you take 1.75 divided by 0.875, what do we get? Divided by 0.875, what do we get? We get a 2. So yes, indeed, this particular set of formulas does obey the laws of multiple proportions.